Okay, so as in the last video we have discussed about formation of MgF2, right? And the lattice energy which was produced along with 1 mole of MgF2, the lattice energy, right? And to calculate the lattice energy we have a very renowned process or cycle. This is what we call the Born-Haber cycle, right? Or Born-Haber process, by what we calculate the lattice energy. Now see, today we are going to understand another example of Born-Haber process, and that is MgCl2, magnesium chloride, right? Okay, so MgCl2, right? Now I know that Mg is found in its stable state in solid form, right? In solid form. Plus Cl is the gas which is found stable in the gaseous form, right? When they both react together, they form they form they form MgCl2 plus MgCl2 plus MgCl2 plus heat of formation, right? Heat of formation. But yeah, what I need to calculate here, the lattice energy, right? And how will we gonna find lattice energy? By making the Born-Haber cycle, right? Initially we need to convert them into gaseous form. When the gaseous form will gonna react together, the 1 mole of ionic compound will form, and along with that 1 mole of ionic compound the energy will be released, and that is what we call the lattice energy. Which means now the step is to convert this Mgs into Mg gaseous form, right? So Mg into gaseous form by providing it with a heat, right? And that is heat of sublimation. Heat of sublimation. Right? Heat of sublimation. Then I need to take out the electrons from Mg, right? I need to make this Mg as Mg plus, right? In order to make it plus, I need to give here energy, and this energy is what we call the ionization energy, right? Ionization energy. We know that Mg electrovalency is 2, right? Plus 2, which means one more electron would be removed from here. So Mg double positive in the gaseous form, right? Which means here I need to give a second ionization energy. Second ionization energy. Now actually we have found Mg double positive in the gaseous form, right? Now I need to work on this chlorine. Now chlorine is in the gaseous form, right? But here I need to break the bond between this chlorine. To break the bond, to make it 2Cl in the gaseous form, I need to give here heat of dissociation, right? Or energy of dissociation. Energy of deassociation. Deassociation. Okay, so now I need to remove one electron from chlorine. Now I need to remove one electron from chlorine in order to make 2Cl negative in the gaseous form, right? So the energy which is released due to adding of an electron to the valence shell of a gaseous ion, this energy, the released energy is what we call the electron affinity. Electron affinity, and this would be released, so negative, right? Now this Mg double positive in the gaseous form will gonna react with two atoms of chlorine negative in the gaseous form in order to make MgCl2, 1 mole of MgCl2 plus lattice energy, right? Now here the energy would be known as lattice energy, since lattice energy is the energy which is released along with the 1 mole of ionic compound produced from the gaseous reactants. So here we have covered another example of the von Haber cycle. We have seen the production of 1 mole of MgCl2, which is ionic compound, along with that the lattice energy.